Okay, so let's go over your station questions today. Okay, so that should be a nice review for your quiz tomorrow. First one, Jessica had 5 batches of brownies. She wants to split up for the class. Each person will get 1/8 of the brownie plate. How many people can she give this to? Well, 5 batches. Okay, so let's get a color here. It helps if you write the number sentence. So if you run the number sentence, so you have 5 batches and you're dividing into eighths. Okay, that's what each person will get, 1/8 of the batch. So if you divide 5 batches of brownie, how many little pieces will you have that you can give out? So 5 divided by 1/8, and I actually shouldn't have written it like that. I should write it like this. Okay, change colors. Step 1, put that whole number as a fraction. Find the LCM. The LCM between 1 and 8 is 8. This particular fraction we don't have to change, but this one we do. It's times 8. So top becomes times 8. Okay, so now it's 40. So now we have 40/8 divided by 1/8. It eventually, you can even imagine it as this because all the pieces are of the same size. So how many times can this piece fit into 40, or what's basically simply 40 divided by 1? If you do what I asked you to do, you can write it like this and then change it to 40, or just simply write 40. So if you had 5 batches, and this one, I think, was it a model? Yeah, it was a model. So sorry, I did all that work for nothing. But here's 5 batches of brownies. 3, and they should have all been the same, but obviously I'm not making it the same because so cut everything into eighths. That's 1 batch brownie. Take a second batch of brownie, cut it into eighths again. Third batch, cut it into eighths. Fourth batch, cut it into eighths. And the fifth batch, cut it into eighths. Now everybody that you want to give this to will get this much, 1/8. Okay, so everybody gets 1/8. So if you have 5 batches and you cut into eighths, how many little batches, how many little, I guess, parts would you have? You would have 1, 2, 3, 4, 5, 6, 7, 8. Each of these is 8. Plus another 8, plus another 8, plus another 8, plus another 8. So you get a total of 40. Okay, people that you can give this to, because you will have 40 little splits here. Okay, so both ways. 2. Larry had 2/3 of a chocolate bar. He decided to give it to 3 of his friends. How much did they each get? Showing a model. Okay, so you know what? Since I started doing this the other way, let me do it both ways. 2/3 divided by 3. LCM is, sorry, put this over 1. LCM is 3 for both. 1 is already a 3. You don't have to make any changes. Here this becomes times 3, and the top times 3. Okay, so your question can be, how many times can 9/3 fit into 2/3? Okay, or better yet, because all the sides are the same size, how many times can 9 fit into 2? Well, write this as a fraction, 2 over 9. Okay, so 2/9 is your answer. Let's see how we represent this as a picture. Take a circle, take a bar, whatever you prefer. It's easier for you. Let's take a bar. And let's shade this because show you that we have 2/3. So this is what we currently have, 2/3 of a chocolate bar. And now 3 of your hungry friends come around and they say, can we have it? So, well, I saw some of this today. If you do this, it's not going to work. Why? Because someone's going to have this bigger chunk. So definitely not the right way to cut this. So, right way to cut this was to take each of these slices, and you know what? Cut this into 3 pieces, and then cut the other bigger piece here into 3 as well. Now, if you count, you have 1, 2, 3, 4, 5, 6. 6 pieces and 3 pieces. This will go to your first friend. These 2 will go to your second friend. And these 2 will go to the third friend. One thing I forgot to do was cut the last piece, even though we don't have it. Okay, we still have to cut that last piece. Okay, so how many, or what did each friend get out of the 2/3 that you had available? For this particular guy right here, he took this piece and this piece. So he took 2 pieces out of how many possible? 9. The second guy, what did he take? He took these 2 pieces, and that's also 2/9. And the third guy also took 2 pieces, which was 2/9. So that matches your answer right here. Okay? 3. He's building tables. He has 6 pieces of wood. Okay, so he has 6 pieces of wood and only need 3/4 to build 1 table. How many tables can he build with 6 pieces, and then how many will he need to build 24 tables? So let's look at the first part of the question. How many tables can he build with 6 pieces of wood? Well, he has 6 pieces of wood. Each table requires 3/4 of the wood. So let's see how many big tables he can build. This does not require you to draw, so let's just quickly put it over 1. 4 is the LCM. This stays the same. This will change times 6. This is also times 6, so you get 36. So again, imagine that this bottom part's not there. Just focus on the top because the denominator is the same. You got 36 over 3, which is the same thing as 12. So with 6, which was original, with 6 tables, I'm sorry, 6 pieces of wood, which is what he had at the beginning, with 6 pieces of wood, he can make how many? 12 tables. That's what this comes out. 12 tables. Okay, so with 6 pieces of wood, he can make 12 tables. Now, how many pieces of wood would he need to make 24 tables? Obviously, with 6 he can make 12, so you need to double that. So he would need 12 pieces of wood to make 24 tables. Okay. 4. How many 2/7 are in 6/7? Show your work using a model. Tricky, very tricky, because for some reason you saw this order in the sentence. The fraction should come up in this order, so therefore you automatically assume that this was your sentence, but it's not. This says how many 6/7 are in 2/7. The correct sentence should have been this. Okay, so this is completely wrong. This says how many 2/7 are in 6/7. So let's draw this out. Take a bar, go 1, 2, 3, 4, 5, 6, 7. Take another bar. 1, 2, 3, 4, 5, 6, 7. Notice that they are of equal size. So you want to highlight 6 on the first one. And I want to change colors. I'll highlight 2 here. So these are all 7th. Okay, so how many times would you be able to take these 2 pieces and fit on top here? Well, you'd fit it 1 time, you'd fit it 2 times, and you'd fit it 3 times. Good, the answer is 3. So prove it this way using the algorithm. Pretend the 7s are not here for a second. Let's just simply 6 divided by 2, which is 6 over 2, or 3, and that matches our picture answer on the top. 5. How many 3/4 are in 11/4? Okay, same thing, use a model. So again, your sentence should have been 11 over 4 divided by 3 over 4, not the other way around. Okay, so let's draw this out. You know it's something cut into 4, so it has to be 4. This is 1/4, 2/4, 3/4, 4/4. So you definitely don't have enough. You might have to draw a little bit more to remember. 11/4 means how many of these little ones, okay, that piece equals 1/4. You need 11 of these, okay, you need 11 of these little squares to make it 11/4. So let's highlight. This is 1/4, just 1/4, plus another one, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9, 10, 11. What does that mean? You actually have 11. You have 11 1/4. Okay, that's what this picture shows. Now, what it also says is that they want to know how many times can something that's cut into 4ths as well, so you know automatically that the pieces are the same size. How many times can you make? Okay. How many times can these three fit in these up here? So these three fit here. Definitely one time. Definitely two times. Definitely three times. So three for sure. But if you take these three and try to fit them in here and here, not all of them will fit, but two of them will fit for sure out of the three that you're trying. Your answer is 3 over 2/3. Now, if you took this and took it with the algorithm, okay, pretend the 4 is not there, okay, these are the same, so we can write it as a fraction, 11 over 3. And if you change this to a mixed number, 3 goes into 11 3 times, 2 left over 3, and you get the same answer we got through the picture. 4 ninths, 5 sevenths, show all your work. It's pretty standard. No mixed numbers, so we don't have to worry about that. Just straight to an LCM, 63. Okay. A lot of times, yes, it is the product of the denominators, but sometimes it's not. Okay. So 9 times 7 times 7, this will give you 28. Times 9 times 9, that'll give you 45. Okay, so you got 28 over 63 and 45 over 63. Quick way of doing this. Ignore the bottom ones and just write that. 28 goes as your numerator. 45, can we simplify that? I think not. Final answer. Okay. Batch of cookies requires 1 1/4 sugar, cups of sugar. How many batches can Sam make with 15 2/3? So your sentence should have been this. You have 15 2/3 cups, and you want to divide it into 1 1/4. Times and plus. 3 times 15 is 30. No, 45, I'm sorry. Plus 2, 47. So that's 47 over 3. Divided by 4 times 1 is 4, plus 1 is 5. 5 over 4. Okay, now that we change our mix to improper, let's find an LCM. This case is 12. Times 4 times 4. 4 times 7 is 28. Goes 2, 16, 1, 88. 4 times 3 on top, it's 15. Okay, so you can think of how many times can 15 over 12 fit inside 188 over 12, okay, or just simply 188 over 15. Geez. You can leave it like that, or if you change it to a mixed number, it's going to be 150, 165, 180, so that's going to be 12, 8 over 15, okay? Remember, read the question. If it tells you to simplify, then you simplify. So King Arthur had a kingdom, and he took 11/12 of his kingdom, and he was going to split his kingdom, not all of it, obviously, 11/12, split into parcels or little plots of 2/9 each. How many little plots can he split it in? So, LCM. Now here is a good example that if you multiply 12 and 9, you would get 108 as your as a common denominator, but definitely not your least common denominator. Least common denominator is 36. Okay. If you use 108, it wouldn't make the question incorrect. You need to work with bigger numbers. So why do you want to do that? So 12, it would be times 3. 12 times 3, you get 33. 9 is times 4, so the top is times 4. 4 times 2 is 8. Okay, they're all the same size, so we can eliminate the denominators. 33 over 8, which simplifies to, if you change the mixed number to 8 goes 33 4 times, 1 over 8. 9. 4.5 laps around the high school track equals 1 mile. Jane ran 28 3/5 laps. That's a lot of laps. How many miles did she run? Well, that's how much she ran. This is how much 1 mile is. 4.5 laps. So how many 4.5s fit inside 28 3/5? That would give us the total number of miles. Let's change this to a improper. The easy one first. 4 times 2 is 8, plus 1 is 9 over 2. 28 times 5, I have no idea. Times 5, carry the 0, 4, 16, 10, 4, 14. plus 3, 143. Okay, so if my math is correct, that is what it is. So now we need a common denominator. Let's just use 10. Okay, times 5 here. Times 5 here is 45. And here's times 2, so therefore the top times 2, and that gives us 286. Everything's the same size, denominator is the same, let's cross that out. It becomes 286 divided by 45. How many times can 45 go into 286? So let's write it like this. Now you can think about how many times that is, I don't know. Let's see, 45, 90, 180, 235, another 90, 270, 180, 270. So 1, 2, 3, 4, 5, 6, 6 times, and you have 16 left over out of 45. Okay, if I'm wrong, okay, correct me tomorrow. Okay, so that's which one is this? The 4.5 laps, the laps around the school. So basically, by running 28 and 3/5 laps, she ran 6 and 16 over 45 miles. That's how much she ran. Okay. Last question, 3 and 3/5 divided by 8 and 1/4. So a big number going to a smaller number. How many times can 8 and 1/4 go into 3 and 3/5? Obviously, not all of it, but a part of it. So our answer is going to be a small answer. Okay, change this to improper. 5 and 3 is 15 plus 3 is 18. Sounds right. 8 times 4 is 32 plus 1 is 33 over 4. Our LCM, it is 20. Times 4 at the bottom, therefore 4 at the top, and that gives us, I don't know, 2, 3, 7, 2. Times 5, and then times 5 on top as well. That's 15. Carry the 1, 16. So you can think of it as how many times can 165 over 20 go over inside 72 over 20, or just how many times can 165 go in 72, because the sizes are the same. So if you're more comfortable, write this down as a fraction first, 72 over 165. And if you can simplify, go ahead. If not, yes, you can. Let's see, 7 and 2 is 9, so it's divisible by 3. At the bottom, 1, 6, and 5 is 12, so that's divisible by 3. So both top and bottom are divisible by 3. Look at that. So 72 divided by 3 is, I have no idea, 3, 2 is 24. 165 divided by 3 is 5, and 55 sounds like a good number. 3 times 5 is 15, goes 1. 3 times, okay. And guess what? It can be divisible by nothing, so we're done. 24 over 55 is your final answer. Okay? And that's that. Hopefully did this help. It did. Hopefully it did help. Okay, and make sure your notebook is updated. And that's it. And maybe not so bad. Please tell me how to stop recording this. Oh my God. Did it record anything? Oh, it did. Hang on a second, guys. Stop. Oh, okay. I forgot. I guess it's still recording. I forgot that word, right? Let's see. No. I need a word quickly because here we go. All right. Alright, now I gotta turn this off, and I don't know how to do this. You can definitely shut it off, so